In this section, we're going to be introduced to a whole new set of identities. Now, everything that we've covered until now are ones that you have to have memorized. But everything that we're going to do starting now, you will be given on a sheet during the test, the final, and wherever else. All right? So, we're first going to start talking about double angle identities. So let's just think about what that means for a minute. Suppose I told you, suppose I asked you what is sine of 30. How much is that? Sine of 30? 1/2. Now, so that's sine of theta, right? So now, if I were to ask you, well then what's 2 times sine of 30? How much is that?
1.
Right, 2 times 1/2, that's 1. So what that is 2 sine theta, right? That's just 2 times sine of theta. Nothing new. Okay, now, what if, again, I had sine of 30 equals 1/2? But now what if I asked you, what is sine of 2 times 30? Well, now it's sine of 60, right? Which is root 3 over 2. A whole other situation than before, right? What have I found now? This is sine of 2 theta, right? So I have changed the angle altogether, right? So whereas before my angle was 30, now my angle is 60. Okay? So that's what double angle means. All right, let's talk about some identities. It turns out there are ways to relate double angles to single angles. So the situation is, okay, is there a way to relate sine of 60 to, still an angle of 30? Well, it turns out there is. And so here are the identities for that. So you see how, you have an identity for sine of 2 theta, but now look at what's inside. It's 2 times sine of theta cosine of theta. So whereas the identity is for a double angle, inside it calls for sine of single theta. So if this was sine of 60, it would be 2 times sine of what? 30, and cosine of 30. All right? So it relates double angle to single angle. All right, tangent of 2 theta, it's this combination of, letters and symbols right there. It calls for the tangent of single theta again. Okay, now look at cosine. For cosine, you actually have 3 variations. Okay, now one is not more correct than the other. They're all equally as correct and they're all equally as useful. Which one you use could be up to you. Sometimes you don't even have a choice. It's just based on what you have given in the moment. Okay? All right. So let's take a look at this. Okay. So I'm given sine of theta is 3 over 4. And I need to find sine of 2 theta, cosine 2 theta, and tangent of 2 theta. Okay, and remember, no triangles, I need to use identities, right? So first of all, if I wanted to find sine of 2 theta, what does that call for? What does that call for? 2 times sine of theta, which I have, and cosine of theta. Do I have that? No. Okay, so before I even start that, I need to find cosine of theta. Is there a way to find cosine if I have sine?
Oh, we know how to do that now.
Yes, we do. How?
So cool.
We use a Pythagorean identity. Okay, so first, use a Pythagorean identity. to find cosine of theta. So sine squared theta plus cosine squared theta is equal to 1. Okay, sine of theta is 3 over 4, and the square of that is 9 over 16, plus cosine squared theta is equal to 1. So subtract 9 over 16. Cosine squared is 1 minus 9 over 16. So cosine squared theta is 7 over 16. So cosine is plus or minus root 7 over 4. Now, normally you will be given information with which you can select, if it's plus or minus, remember, like with the quadrants. How about for this one, let's assume that we're in quadrant 1. So we're going to take the positive one. Okay, now I can start on my problem. Yeah, root 7 over 4. So now, number 2, I need to find sine 2 theta. Okay. Identity says 2 sine theta cosine theta. Okay. That's 2 times sine of theta is 3/4. Cosine is how much? Root 7 over 4. So sine of 2 theta, okay, look, 1, 2 cancels with this 2. So 3 root 7 over 8. Isn't that fun? Waiting. So the 2 and the 4 cancel. So this is a 1 and a 2. Now I have 3 root 7 on top, 8 on the bottom. Okay, 1/3 of the problem down. Let's go to cosine of theta. Cosine of 2 theta. Okay, so cosine of 2 theta, we can use any one of those. Which one do you guys want to use? Oh, now it's a rivalry.
Fourth one.
Let's do the second one. Let's do the second one. So it's 2 cosine squared theta minus 1. This is 2. The square of root 7 over 4 minus 1. Yes, sir.
Why can't you just take the original cosine of theta and then multiply that by 2?
No, because that would be 2 times sine of theta, right? But now this is sine of 2 theta, so we're changing the angle.
Oh, so like if the 2 were to be like in front of the cosine,
right,
you could do that? But since it's in front of the theta.
Right, correct,
right.
Correct. So this is 2 times 7 over 16 minus 1. Again, cancel the 2's. So this is 7 over 8 minus 1. How much is that? Cosine of 2 theta, negative 1 over 8. Yes.
Never mind.
You're sure?
Yeah.
Okay.
You just didn't like this thing, so I didn't see it. Didn't like it.
Oh, here, yeah.
Like you did it.
Okay, now, look at what happened here. Sine is positive. Cosine is positive. All of a sudden, cosine of 2 theta is a negative value. Can that be possible?
No.
Why not? Cosine is always positive. Okay. Cosine is positive where? In quadrant 1 and in quadrant 4. Okay. So now, where did I say my angle was? In quadrant 1. So theta is in quadrant 1. But this is not cosine of theta. This is cosine of 2 theta. Okay. Tell me, what does this now tell you about the possible values of this angle? We don't know what the angle is.
It's in the second quadrant.
So we said the angle was in the first quadrant. Okay? So now look at this. Suppose the angle was 30. Where would 2 theta be? First quadrant, and the cosine would be positive. Suppose the angle was 50. Where would 2 theta be? Second quadrant, and what would the cosine of that be? Negative. Okay? So where is the break point? After what angle is 2 theta going to go into the second quadrant? 45. So when the angle is 45, 2 theta is 90. But the minute the angle turns into like 46, then 2 theta is 92 in the second quadrant. So the cosine of 2 theta would be negative. So it is possible. So this tells us that theta has to be greater than 45 degrees. Tell me how cool that is, right? It takes a while to wrap your head around, but it's really cool. All right, so third, we have to find tangent 2 theta, huh? 4. Just like quadrants. Okay, now, how am I going to find tangent 2 theta? Okay, there is an identity here. Tangent 2 theta calls for tangent theta. So you do 2 tangent theta, 1 minus blah, blah, blah. Okay, do we have tangent theta yet? No. I don't have, I have sine and cosine and I could find tangent, but I don't have tangent theta yet. So I would have to find tangent theta, then put it in this formula. Okay, that's not a very, it's a kind of a ugly looking thing, right? So now, I'll take your question in a second. Do you have a question or a? Okay, so listen. Let's think about tangent for a minute. What's sine over cosine? Tangent, right? What's sine squared over cosine squared? Tangent squared. So now, guess what? Turns out sine of anything over cosine of anything is tangent of that same thing. So if I had hypothetically sine of 2 theta, and if I had hypothetically cosine of 2 theta, that would equal tangent of 2 theta. So to find tangent of 2 theta, yes, I could do this identity. Or alternately, I could say tangent of 2 theta is sine of 2 theta, cosine of 2 theta. Do I have sine 2 theta, cosine 2 theta? Yes. I just found them. So this is sine 2 theta, which is in the red, over cosine 2 theta, which is in the blue. What cancels here? The 8's. So I have 3 root 7 over negative 1, negative 3 root 7. Look, that 2 is negative, right? Because when my angle was in the first quadrant and 2 theta went into the second quadrant, over there tangent is negative 2. And now we're done. Question? Okay. Let's solve a problem, okay? So, cosine 2 theta minus cosine theta is equal to 2. What's the problem here? What's the issue? What's the issue here? What do we have a mix of? A double and a single angle. Not cool. It has to be all in terms of single angles, okay? So convert 2 theta to theta. If only there was an identity that converted cosine 2 theta into a single angle. Is there? There is. Now, cosine 2 theta has 3 alternatives, right? Which one am I going to use? First, second, or third? Why the second one? Right. The rest of this equation is in cosine, right? So I don't want to use the first one because I don't want to mix signs with it. And I don't want to use that one because I don't want to mix signs with it either. So I use the second one because that's when it'll all be just, you know, homogeneous, okay? You can't have a double and a single, so I have to convert 2 theta to theta. So this is going to be 2 cosine squared theta minus 1, and the rest of the equation stays as is. Okay, now let's bring everything to the same side and set it equal to 0. Don't you guys love math? Okay. Okay, now I need to factor this, but first let's write it in like proper order. So 2 cosine squared theta minus cosine theta minus 3 equal to 0. Okay, now to factor, you could do guess and check. Is everybody okay with guess and check, or should we do that other method where you multiply the 2? Let's do that other method.
No. What's the other method? Yeah.
So you multiply the 2 over to here. So now you get cosine squared minus cosine minus 6. So you have cosine, cosine. How am I going to get minus 6 and minus 1? Negative 3 and positive 2. But because I took out the 2, I put it back. So now I have 2 cosine minus 3 cosine plus 1 equal to 0.
How do you know?
Why did you do cosine? Why wouldn't you do like 2 cosine plus 2 and then like cosine theta minus 3 Right, but like see how you got rid of the why how do you know you can get rid of the 2 on the side of another?
Oh, because you look at each parenthesis and see if you could divide both terms by the same number. Okay. And that one you can, that one you can't. Okay. Now, do we have 2 things multiplied by each other and equal 0? Yes. So can we set each one of them equal to 0 on their own? Yes, we can. So 2 cosine theta minus 3 equal to 0. Cosine theta plus 1 equal to 0. Add 3. Divide by 2. Cosine is 3 over 2. For what angle is cosine 3 over 2? None, right? Because it's greater than 1. So none here. Cosine is equal to negative 1. So theta is pi. And that's it. Just pi. Nice. It is nice. Okay. Okay. All right. So, okay. You know how, okay, you see how this is one of the double angle identities? That's the middle, no, the third cosine over there, right? Okay. So, most of these identities we've seen before. You can just take one identity, do some math to it, and grab another, like, convert it to another identity, right? Like, what was it? Like the Pythagorean identities, we divided by sine and we got the second one, and we divided by cosine, we got the third one. So look at this identity. We're going to solve this for sine squared theta. So let's solve this for sine squared theta. I'm going to subtract 1. Okay? Now, divide everything by -2. So I get sine squared theta on the right side equal to cosine 2 theta minus 1 over -2. And okay, so we never leave the -2 just on the bottom like that, the negative in the denominator. So I can move the negative up, and I can write that this is negative cosine 2 theta minus 1 over 2. And then I can distribute the negative, and I can say sine squared theta is positive 1 minus cosine 2 theta. We always like to write the positive one first and then the negative because, you know, it never looks good to have like a dangling negative in the front, right? Over 2. Now look. Look at that. And look at that first identity here. You see how it's the same? So you see how this is just another version of the identity up in that box? All right? You can use these versions as power reducing identities. Okay, so what does that mean? Let's look carefully for a minute. Look at what this does. This takes sine squared exponent of 2, and the end result is an expression with no exponent higher than 1. So it reduces the exponents down to 1. You see that? That's why it's called power reducing identities. Sometimes it's necessary for us to do that. Okay, so look at this problem here. It says, rewrite cosecant to the 4 in terms of cosines of multiple angles with no power greater than 1. So what does that mean? I'm not allowed to have any exponents greater than 1. What I am allowed to have is a whole bunch of cosines, and the angle could be multiple angles, 2 theta, 3 theta, 4 theta, whatever I want. Okay? All right, let's do that. Yeah. Okay, do I have, okay, so I have an exponent of 4, but I want no exponent greater than 1. That means I need to reduce the exponent, right? So, power reducing formula. Do I even have one for cosecant? No, but what's cosecant the same as? Sine, right? 1 over sine. So first, why don't I write this as 1 over sine to the 4 theta. Well, now you're saying, well, that's great, Miss Malikian, but we don't even have an identity for sine to the 4th. We have it for sine squared. You can do what? Square of a square, right? Okay, so why don't we do 1 over sine squared theta squared? That's still the same thing, no? Now, look at this. This sine squared theta, we don't want it because it has a power of 2. Is there an identity? No. Yep, that first one over there. So that's going to be 1 over that identity, 1 minus cosine theta over 2. 2 theta. Now we're going to do that. All this squared. But what's up with this complex fraction? 1 over, 1 over, 1 over, right? What's 1 over something? the reciprocal.
Yeah.
So why don't we say that this is just 2 over 1 minus cosine 2 theta squared. I know. Yep. Oh. 1 over is another word for reciprocal. I know. Okay, learn something new every day. So now what?
Square.
Okay, so now you're thinking, oh my god, look, I did it. I got rid of all the squares, like no more exponent higher than 1,
Square.
except for that one over there. Okay, now we have to deal with that one over there. What we're going to do is we're going to distribute that square to everybody inside. So, this guy, this guy.
You squared or we just write it?
We square.
I was gonna write like 2 squared.
So, that's 4 over. Now,
Then you can
we're going to square, listen up, we're going to square this. It's 2 terms. When I square it, how many terms should I have? 3. So it's going to be 1 minus 2 cosine 2 theta plus cosine squared 2 theta. Darn, I have a square again. Okay, so now I need to get rid of this. Okay, so this is going to be 4 over 1 minus 2 cosine 2 theta plus, okay, I need to change that thing in the red. Cosine squared 2 theta, can't have that. If only there was an identity that would reduce a cosine squared to a regular cosine. Oh, but there is. But, look at what this identity does. Yes. Yes, you do. Because look at what this identity does. Cosine squared, what single theta? Equals 1 plus cosine twice the theta. Okay? So one thing the identity does, yes, it reduces the power, but what does it do to the angle? Doubles the angle. All right? So if this is theta, it becomes 2 theta. If this was 3 theta, it would become 6 theta. Okay? Whatever the angle is here, it doubles there. So here, it's going to be 1 plus cosine 4 theta over 2. We're like 80% done. Yes, you do. What do you want to do about the 2? Let's multiply all of this by 2. That would get rid of that 2 in the bottom. But then you have to do the same to the numerator. Huh? Because remember we said this identity, it takes the angle and doubles it. Angle, double angle. 1 theta, 2 theta. 2 theta, 4 theta. Here we have 2 theta. Now we have 4 theta. Okay, multiplying everything by 2. Why not? You have one on the homework. Okay. 8 on top. Okay. 8 on top over. Let's multiply. 2 minus 4 cosine 2 theta plus 1 plus cosine 4 theta. Okay.
Wait, you don't multiply the 2 theta? You're getting rid of the denominator, like this.
No. This theta, you mean?
Yeah.
No, because so if you have like 2 times sine of theta, right? That 2 doesn't multiply with the theta. Yeah. Okay, now look, we're almost done. What's the one thing left? Just combine those 2. 8 over 3 minus 4 cosine 2 theta plus cosine 4 theta. Now, let's read the directions one more time. Okay? Do we have this written in terms of cosine? Yeah. Okay. In math or physics or science or whatever, when it says to write something in terms of something else, it means, so when write in terms of cosines, it means you're obviously going to have cosines, but not anything else. Okay? So that's what we have here, cosines, but no sines, so we're good. Multiple angles, that's good, 2 theta, 4 theta, that's allowed. No power greater than 1. Is that what we have?
Yeah.
That's what we have. So we're done.
So we're saying cosine is kind of like a hint that like that's the formulas that it's gonna.
Right.
Like,
It kind of guides you, yeah, that it's going to be in terms of cosines.
like it makes sense.
Yeah.
Like doing it on my own.
Yeah. Okay. So now,